Zeal Education Society, redefining excellence.
Welcome back. In the previous lecture, we have solved one numerical example on jury stability test. In continuation to that, we will solve a couple of more examples in this class. We will start with the first example. The example is, investigate the stability of the system with characteristic equation. The characteristic equation is given. So let us start. We have P of Z equal to Z cube minus 1.1 Z square minus 0.1 Z plus 0.2 equal to 0. And let us start with the necessary conditions. The first one, we have to find out P of 1. What is P of 1? This is 1 minus 1.1 minus 0.1 plus 0.2. So it is equal to 1.2 minus 1.2. So it is 0. So it is neither greater than 0 nor less than 0. Now here the case is that the system may be marginally stable or unstable. We have to check it. Then the second condition is minus 1 raised to n. P of minus 1, so here n is 3, so this will be minus. P of minus 1 is minus 1 minus 1.1, this will be plus 0.1 plus 0.2, so this is minus 2.1 plus 0.3, so minus 1.8, so minus minus plus, this is 1.8. So this condition is satisfied. And now the third condition, here modulus of an is equal to modulus of a3, and this is modulus of 0.2 is 0.2, and modulus of a0 is equal to 1. So modulus of an is less than modulus of a0, and that means all necessary conditions are satisfied except this one. So here it is on the boundary, correct? Now let us construct the jury table. So n is 3, so total number of rows will be also be 3. So row number 1, 2 and 3, and the elements will be say from z raised to 0, z raised to 1, z square and z cube. And let us start writing down the elements. So z raised to 0 has coefficient 0.2, 0.2 minus 0.1 minus 1.1, 1, and then in the reverse order in row 2 minus 1.1 minus 0.1 and 0.2. And now let us find out these coefficients, B2, B1, B0. B2 will be equal to these two elements 0.2, 1, and these two 1, 0.2, and this is equal to 0.2 square minus 1, so it is minus 0.96, minus 0.96. Now let us find out B1. For B1, it will be 0.21 minus 1.1 minus 0.1. So it is equal to 0.2 into minus 0.1 plus 1.1. It is 1.08. So let us write down these values immediately here. This is minus 0.96, 1.08, and the last one is let us find B0. For B0 this will be 0.21, and these two minus 0.1 minus 1.1, and it is equal to 0.2 into minus 1.1 plus 0.1. So it's minus 0.12, minus 0.12. And let us go for the sufficiency conditions. So what we have here, modulus of B2, modulus of minus 0.96 is 0.96, modulus of B0 is equal to 0.12, so modulus of B2 is greater than modulus of B0. And that means all conditions, so all conditions are satisfied except P of 1 equal to 0, correct, or greater than 0, and I will write here where P of 1 is equal to 0, and that is on the boundary. So system is marginally stable. So what we will do, we will do a cross verification, we will have a check. Let us find out the poles of this. So P of Z is equal to Z cube minus 1.1 Z square minus 0.1 Z plus 0.2 equal to 0. And now let us find out its roots using calculator. And its roots are, if your calculator does not have this facility, you can go by synthetic division. Z equal to 1, then 0.5 and minus 0.4. And that means P of Z is equal to Z minus 1 into Z minus 0.5 into Z plus 0.4. Correct. And now just do an exercise that let us have the pole 0 plot in the Z plane. So this is Z plane. Let us mark all poles. So one pole is at Z equal to 1, second pole is at Z equal to 0.5, and third pole is at Z equal to minus 0.4. Now look at this. A non-repeated pole is on the circumference of unit circle. This is unit circle, while remaining poles inside the unit circle. Hence the system is marginally stable. It is cross-verified. Correct. Let us start one more example. Now we will consider the fourth order system. So calculations will increase. You should have experience of this also. Investigate stability of system with characteristic equation P of Z equal to Z raised to 4 minus 1.2 Z cube plus 0.2 Z square plus 0.05 Z minus 0.001 equal to 0. Now in this case there will be 5 rows in the jury's table. And how to find this? Obviously using jury's stability test. Let us solve this example. Here you need some patience while calculating, because all numbers are non-integers. Doing calculation is tedious, but still we have to do it. We have P of Z equal to Z raised to 4 minus 1.2 Z cube plus 0.2 Z square plus 0.05 Z minus 0.001 equal to 0. And let us start with necessary conditions. So the first condition is P of 1 shall be greater than 0. Let us check what is P of 1. put 1 instead of z, so 1 minus 1.2 plus 0.2 plus 0.05 minus 0.001, and that is equal to 1 minus 1.2 plus 0.2 plus 0.05 minus 0.001, it is 0.049, that is greater than 0. Next condition is minus 1 raised to n p of minus 1. So here n is 4, so minus 1 raised to 4 is 1. No need to move ahead. Directly we will put here minus 1. So this is 1 minus plus 1.2 plus 0.2 minus 0.05 minus 0.001. Just I have substituted z equal to minus 1. That is equal to 1 plus 1.2 plus 0.2 minus 0.05 minus 0.001, and it is 2.349, which is also greater than 0. So this is the condition number 1, condition number 2, and now let us go for condition number 3. In this case, modulus of an is equal to modulus of a4, and that is equal to modulus of minus 0.001 is 0.001, and modulus of a0 is 1, and that is modulus of an is less than modulus of a0. So all conditions are satisfied. Now let us move for the jury's table. Here you will have 5 rows, 1, 2, 3, 4 and 5, and that will be z raised to 0, z raised to 1, z square, z cube, and z raised to 4. And let us put the elements. So this will be minus 0.001, then next is 0.05, next is 0.2, then minus 1.2, and finally 1, and just reverse 1 minus 1.2, 0.2, 0.05 minus 0.001. And now we have to calculate B3, B2, B1, B0 and C2, C1, C0. So 7 elements we have to calculate. Let us calculate one by one. B3 will be equal to these two and these two elements, minus 0.001, 1 minus 0.001, that is equal to 0.001 square minus 1, this is log number 0.69. You cannot round up this. If you have to round up, it will be minus 1 only, nothing else. Then B2. For B2 it will be minus 0.0011 and these two. That is minus 1.2, 0.05, and it is equal to 0.001 into 0.05 plus 1.2. Yes, it is 1.19995. Then B1. For B1 it will be minus 0.0011 and these two. So 0.2, and it is equal to 0.001 minus 0.2002. Then we have to find out B0. For B0 this pair, that is minus 0.0011, 0.05 minus 1.2, and it is equal to minus 0.001 into minus 1.2 minus 0. So it is coming minus 0.0488. Let us enter these numbers here. So it is minus 0.999999, 1.19995, minus 0.2002, and minus 0.0488. And now shuffle. Minus 0.0488, minus 0.2002, 1.19995, and minus 0.999999. And now we have to find out C2, C1, C0. So here C2 will be equal to what? These two and these two. And this is equal to 0.9976. 0.9976. Next is C1. For C1, we will have these two and these two. And this is equal to 1.2097, and then C0, these two and these two. So it's minus 0.999999, minus 0.0488, and 1.199995, minus 0.2002, and this is equal to this point. Point 2588. Here I have minus 1.2097 and 0.2588. So here n is 4, so there will be two sufficiency conditions. So let me mark the sufficiency conditions. For the sufficiency conditions, number 1, I have modulus of B2 is equal to 0.999999, and modulus of B0 is 0.0488. So modulus of B2 is greater than modulus of B0. Satisfied. and then the second condition, not B2, this thing shall be B3. Modulus of C2, this one is 0.9976 and modulus of C0 is 0.2588. So modulus of C2 is greater than modulus of C0. And now you look at this. These three conditions are satisfied. These two are also satisfied. So system is stable. So we have solved couple of examples and it is enough. So we have covered the jury stability test in detail. In the next lecture, we will go for another method, that is combination of bilinear transformation and root stability test to investigate the stability of digital control systems. Let us meet again. Thank you.